Okay, guys, sorry I got cut off, so it's going to go a little over 15 minutes, but we're almost done here. Okay, so like I was saying, in order to combine the resistors in a parallel circuit, we have to combine them differently. So it's going to be 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3, and that's how we combine them. So be careful that when you get R total, you add all of these fractions up and then you do 1 over that to get the actual R total. So if we do this, it'd be 1 over 10 plus 1 over 10 plus 1 over 20, and you'd get the R total to be 4 ohms. Okay, and that's the total R in the whole circuit. Now, if we wanted to know the total current in the whole circuit, we would just do V equals IR using the total voltage, which is 3 volts, equals I, and our total resistance is 4. So we get a total current of 0.75 amps. Okay. Now, 0.75 amps is not going through each of these. Remember, it's different because the number of trucks that go to each of these depends on how much resistance they have. So not every single one is going to get every single truck. They can't go every single house. So the way that it breaks up is based on the resistance. Okay, and these two houses will get the same number of trucks because they have the same resistance. But this one will get a different number of trucks than these two. The way we figure out the current through each of these resistors is we take the voltage drop, which is 3, and we use V equals IR on that one resistor. So the V would be 3, that's the voltage drop, I is what we're looking for, and R is 10. So the I across that resistor is 0.3 amps. What you'll notice is that 0.3 amps is across here, 0.3 amps is across here, and you'll get the right amount across here, be like, I think it's 0.15, let's check. 3 divided by 20. It's 0.15 through this one. So if you notice, it'll be 0.3, 0.3, 0.15. If you add those up, you get 0.75. That's the total current. Because the total number of trucks that have to go through all 3 houses has to be the total number of trucks that came out originally. Okay? So hopefully that makes sense. We can explain more when we get to class. The last thing that I want to talk about is power. So if you could go back to your original notes, okay, and just look at the bottom, the very bottom. We have electric power. I just want to give you the equation for that. It's not a big deal. It's really easy. You just be plug and chug kind of stuff. Technically, there are 3 equations for it because you can rearrange it, but we use P for power. Okay, it's just the rate at which electric energy is transferred through a circuit. And the equation, there are 3 of them. So I squared times R you can use. You can also use IV, okay, or you can use V squared over R. The reason there are 3 is because if you sub in V equals IR in here, you'll notice if you sub in IR, you get I squared R, and that gives you this one. Or if you sub in IR here, you get I squared R squared over R, so you get IR squared. So it ends up being the same thing. And the units for power are still watts, okay? I know the cookie thing is a little bit weird. I want to just put a note here for you and just kind of show you. So I is the current, and that's the number of trucks per second, okay, that pass by. And then the R is the resistance, okay? Okay, and then the V is the number of cookies per truck. Okay, and we're going to be using this analogy throughout the rest of the unit, so hopefully it'll start to make sense. But we can go over a few examples and any questions that you have in the beginning of class on Friday. Okay, so that's the end of the notes. If you have any specific questions you need answered, like right now, just comment on the video and I will try to get back to you. Otherwise, I'm just going to write down the most common ones and we will go over those during class on Friday. We will talk about the cookie analogy more on Friday, so don't panic if it's a little confusing for you right now.